Hello everyone, my name is Rupali from Computer Science and Engineering Department. Today in this presentation, I am going to introduce about the subject Design and Analysis of Algorithm, which is included in 5th SEM CSE BTech program. This subject is one of the core subjects in computer science. So outline of my presentation will include introduction, why, properties, application, syllabus content unit wise. So what is an algorithm? An algorithm is a finite set of steps or instruction to solve a problem. Basically, an algorithm, for taking it a real life example, if I take, so while building an house, we first create a map and then only we move ahead for building, for construction of building. But if we want to make any changes, we should first reflect it in that map and then only move ahead. If we construct a building and then if you want to make any changes, then we need to destroy it and again construct it, and it will be time consuming and resource consuming. So similar with the programming language, if you want to construct a program, first we need to design an algorithm and then only we can move ahead. So basically, algorithm is the best way to represent the solution of a particular problem in a very simple and efficient way. Basically, if I design an algorithm, I can implement that algorithm in any programming language. So what is the need of an algorithm? The need of an algorithm is that we should understand the basic idea of a program, to find an approach to solve that program, to improve the efficiency of the existing techniques, to design the basic algorithm by using the basic principles of designing. An algorithm should give a clear description of requirement and goals of a program, and good algorithm will always develop a good solution. And we can also understand the flow of a program. After analyzing the algorithm, we can also compute the time and space complexity of an program. And after analyzing space and time complexity, only we can move ahead for designing, and it will also reduce the cost of designing. So properties of good algorithm. So properties of good algorithm includes input and input. Before designing any program, we should always know what are the input requirements of that program. Once we have collected it, then only we can move ahead with the processing part. So an algorithm can have 0 or more input. Output, there should be at least one output for a program. Definiteness, each instruction which we are writing should be very much clear and understandable. Finiteness will include the steps which we have written should be always be finite, whether it may be 10 or 1000, but it should be finite, it should not be infinite. Effectiveness, every instruction should be fundamentally carried out. For example, if we are writing any instruction, it should be very much clear and appropriate to solve a problem. But if that problem is not solving, that step is not solving the problem, that should not be included. So these are the few real world examples of an algorithm. All the problems which we are solving is the example of an algorithm. So these are the few which I have listed: classifying object, facial recognition, Google search, traffic lights, bus schedules. So in our syllabus, these are the 5 units, and these units will contain the following contents. The first unit consists of definition of an algorithm and brief explanation about the basic properties of algorithm. Recurrence relation, and recurrence relation is basically a equation, that is a function which is in terms of its value on smaller values, and this recurrence relation can be solved by using characteristic root equation and master theorem. Asymptotic notation are basically the time the algorithm is taking to be solved. It may be big O, big omega, big theta. That is worst, average, and best case. So here are few sorting algorithms which in our subject we will study forward, so that we can analyze the time taken by this algorithm to be solved, which is insertion sort, selection sort, and bubble sort. By analyzing these algorithms, we can find the time taken by this algorithm, which is order of log n time. So moving ahead, we will also study biotonic sorting network, which is a comparison based network, and it reduces the time, which is order of log square, and it also takes hardware requirements. So basically, we don't use biotonic sorting network. In unit 2, we'll study divide and conquer strategy. Basically, divide and conquer strategy is dividing the programs into subprograms, and the subprograms are reflection of the original program, and these subprograms are then solved and to obtain the final solution. In divide and conquer strategy, we have binary search, quick sort, merge sort, heap sort, Staten matrix multiplication. In this matrix multiplication, if we are using the traditional method, it will take order of log n cube time, and Staten matrix multiplication will take order of log order of n raised to power 2.8 time. So which has been reduced. In greedy approach, we move forward by obtaining the best solution at that particular moment, irrespective of other solution. And in this approach, we will study knapsack problem, optimal merge pattern, and Hoffman coding. In third unit, that is dynamic programming. In dynamic programming, we'll study the basic strategy, multi-stage graph. In multi-stage graph, we will use forward approach and backward approach. In multi-stage graph, we find the distance from source to its destination, the minimum distance. Then it is longest common subsequence, matrix chain multiplication, optimal binary search tree, 0-1 knapsack problem, traveling salesman problem, and single shortest path using Bellman-Ford algorithm. In this algorithm, we find the shortest path from a single vertex to all other vertices, and it is done in directed acyclic graphs. All pair shortest path using Floyd-Warshall algorithm. In next unit, we'll study the basic traversal searching techniques, which is breadth first search, which uses queue data structure, and depth first search, which uses stack data structure. And further, we are going to study the backtracking. Backtracking means we are further moving with a particular solution, and if we find the optimal solution, then only we'll continue, else we will backtrack it to the previous steps. So here are n-queen problem and their analysis. N-queen problem can be also used for solving VLSI testing problems. Graph coloring is basically used in register allocation problems, and for timetable scheduling. Then Hamiltonian cycles also we are going to study in this unit. In unit 5, we are going to study the P problems, which are polynomial time problems. The problems which can be solved in polynomial time, whether it may be log of 1 time, log of n time, log of n square time, but it will be always be solved in polynomial time. But NP problems are non-deterministic problem, means it may be taking more time. It cannot be determined that it will be always be solved in polynomial time, but the solution checking of NP problems can be done in polynomial time. If you want to check the solution, whether the solution is correct or not, it will be done in polynomial time. And further, we are going to study NP hard problems. NP hard problems means first converting that NP hard problem to NP problem, and then solving it. And it is very much complex and difficult problems. Moving ahead, the course outcome of these subjects are basically students at the end of this subject will be able to analyze and design the effective algorithms. Students will also be able to apply various divide and conquer strategy and greedy approaches for solving the computational problems. They can also solve real-time problems using the concept of dynamic programming. They can also solve graph traversal techniques for real-world problem solving. They can also classify for NP complete and NP hard problems. These are the few textbooks which we can use for our course, that is design and analysis of algorithm. These are the few reference books which are also been included in the syllabus. Thank you.